Vision IB, where physics becomes clarity.
So hello my dear students, this is the second part on thermodynamics topic. We had already discussed about the basics of thermodynamics in our first video. If you haven't watched that video, please go and watch that video. The link is given in the description. Secondly, I would like to tell you that in the previous video we had already studied like where do we find the real life application of thermodynamics, why do we need to understand thermodynamics, and we also discussed some important concepts like zeroth law of thermodynamics. We also studied about discussed about different types of wall, that was adiabatic wall and the diathermic wall. We also studied about the state variables, that was intensive state variable and the extensive state variable. We also studied the concept of internal energy, but in this lecture I am going to start from the concept of internal energy again, because I think like from thermodynamics point of view the concept of internal energy is very important. So if you had watched my previous lecture, you must have known that internal energy internal energy is denoted by U, and it is the sum of kinetic energy plus potential energy. So if we look at it in the terms of thermodynamics, we will understand that kinetic energy. What is kinetic energy? Kinetic energy is the jiggling of the molecules in a system. Like the jiggling of the molecules is called as kinetic energy, and the bond between those molecules is called as potential energy of a system. That total comprises of internal energy. That's what we call it as internal energy, right? So internal energy is a path independent variable. It does not depend on a path. So it is like a state variable, as I had already discussed. Like it is an extensive state variable. It is an extensive state variable. So it does not depend on the path taken. After we had covered the important concept of internal energy, let's move on to another slide and see some more concept. So the question comes, we have studied about internal energy, but the question comes, how can we change this internal energy? This internal energy can be changed through two ways. First, either you supply heat, or either the work is done, or either the work is done. So if I were to explain you about the internal energy is increased when the heat is transferred to the system or work is done on a system. This is the standard thing or the standard definition of how can we change the internal energy. Like I'll give you a simple experiment. I'll like you can try it in your home. This is a simple experiment to determine how the change in internal energy affects, like how heat and work done affects the internal energy. So I have this example. So a balloon inflates in hot water and deflates in cold. So what is happening? So first, the material you need for this experiment is an empty plastic bottle, a balloon, a ball, and a ball of hot water, approximately around 60 to 70 degrees, and a ball of cold ice water for the second experiment. So for the first experiment, just stretch the balloon over the mouth of a bottle at room temperature, and just put that hot bottle inside the hot water. After 1 or 2 minutes, the balloon will inflate. So what is happening here is, when you put the bottle with the balloon inside a ball of hot water, what is happening is the gas inside those bottle, or the molecules of the gas inside those bottle, starts to jiggle. They gain internal energy, and as they gain internal energy, the balloon expands. Similarly, so there is, in a simple words, if I say why this is happening, is because of the hot water, the internal energy of the water, the internal energy of the gas has increased, and which caused the balloon to inflate. Secondly, if we look at the second experiment, now stand that same bottle, now put that same bottle with a stretched balloon on the top of that bottle into the cold water. Now what is happening in that cold water? And when you put that in the cold water, the balloon deflates. And why the balloon is deflating? Because of that cold water, the temperature of the gas inside that bottle has gone down, the jiggling of the molecule just slowed, and because of that balloon deflates. And this is the reason why the balloon is deflating in the cold water and why the balloon is inflating in the cold water, in the hot water. So in the hot water, what is happening there? There is an increase in the internal energy in the hot water, and in the cold water, there is a decrease in the internal energy. So this is the best experiment. You can try it at home to check the concept of internal energy through heat transfer. Now you can please take the screenshot of this experiment and you can try it in your home. This is a very simple and the basic experiment to understand the concept of internal energy or change in internal energy. So again, let's go to the basic. As I have told you, internal energy can be changed through two ways, only by the heat transfer and second by the work done. So after we have covered the concept of internal energy, we have understood how can we change the internal energy. Now let's move on to the very important law of thermodynamics, that is first law of thermodynamics. And after understanding all these things, I think you guys are ready for understanding the first law of thermodynamics. So let's look at the famous first law of thermodynamics. So what first law of thermodynamics states that you cannot create energy, neither you can destroy it. Like it was in my own words, but if I were to talk in terms of the definition, you cannot create, and like energy cannot be created nor be destroyed, but it can be transferred in one from one form to another form. So what does the first law of thermodynamics include? So after understanding the first law of thermodynamics, you will come to know that the first law of thermodynamics include the concept of heat, it includes the concept of work, and it includes the concept of internal energy, right? So let's look at the first example. In the first example, what you see, you can see that we turn on the light switch, that is mechanical energy. That mechanical energy got converted into light energy after you turn on the switch, and as the bulb glows, it produces heat. So some of that light energy got converted into the heat energy. So in this process, you can clearly see that energy has neither been created nor been destroyed, but it has been transferred from one form to other form. Like you turn on the switch, the mechanical energy got converted into the light energy, and as the bulb glows, some of the light energy got converted into the heat energy. Now let's move on to the very famous example. Like every one of you must have studied the concept of boiler, turbine, and a generator. So I'm not explaining you this in much technical detail. I'll just tell you about the energy transformation that is taking place here. So what is happening here? You see this coal. This coal has a chemical energy, right? So what is happening is this chemical energy is used to heat the water. So this chemical energy is converted into heat energy. Now this heat energy is now because of that heat energy, the steam is generated inside the boiler, right? And now what is happening, because of this heat energy, the turbine runs. The turbine runs because of this conversion of heat chemical energy to heat energy. This turbine runs. So what is happening here? In simple terms, if we were to look at it, the heat energy got converted into mechanical energy, which runs like the turbine is running. So that heat energy got converted into mechanical energy because of that turbine. Now this turbine in turn rotates the generator. So what is happening is the chemical energy got converted into heat energy got converted into mechanical energy, and now that mechanical energy got converted into electricity, so with the help of an electrical generator. So this is how the energy conversion is taking place. So in both of the example, you see that there is the concept of heat, there is the involvement of heat, work, and internal energy. But you can see that in any of this process, energy was not created. Like this is a basic term to understand, like energy was not created in any of this system. Like it was just transformed from one form to other form. Like from in the first example, it was converted from mechanical to light energy to heat energy. In the second example, it was converted from chemical to heat energy to the mechanical energy to electrical energy. So now I guess you understood the basics of the first law of thermodynamics. Now let's have a look at some mathematical expression for the first law of thermodynamics. So the first law of thermodynamics states that Q is equals to W plus delta U, where Q is the heat given to the system, and work is W is the work done by system, and delta U is increase in the internal energy, right? So what do we see from this equation is, like whatever heat that we supply to the system, some of the heat gets converted, like some of the heat is used to increase the internal energy of a system, and the remaining heat is used to do the work, like a work is done by the system with that remaining heat. So consider it with your example, like if your mother gave you 100 rupees to buy some vegetables, and if you buy those vegetables for just 90 rupees, so you can use that, you have 10 rupees in balance, so you can use that 10 rupees for your further use or whatever you want to buy with the 10 rupees. So it's like what we learn from that example is that whatever heat is supplied to the system, some of the heat is used to increase the internal energy, and the remaining heat is used to remaining heat is used to do work by a system, right? So this is the first law of thermodynamics. This is the mathematical expression of first law of thermodynamics. If we rearrange the term, we can write in terms of internal energy in this manner, like where delta U is the internal energy, Q is the heat given to a system, W is the work done by the system. Now, if we were to conclude, what do we understand from this first law of thermodynamics? See, you can look at the concept of heat and work. So, heat and work are path independent. No, sorry, heat and work are path dependent, while delta U is path independent. So if we were to look at heat and if we were to look at work, first separately, if we consider both of them separately, we understand that heat is path independent, path dependent, and work is also path dependent. But when we look at the combination, but when it comes into the combination like Q minus W, it becomes path independent. So we have this delta U. So why I am saying that Q minus W is path independent, because delta U is the internal energy, and we have already discussed that internal energy is a state variable. It's an extensive state variables, and we have also studied that state variables are path independent. So if delta U is path independent, I can say that Q minus W is also path independent. So this was the basic takeaway that we can that we can understand from the first law of thermodynamics. Now we have to understand the sign conventions that will help us in solving the numericals that I will be uploading in the next videos, like the coming videos. After we complete this thermodynamics lecture completely, we will be solving the numericals, and in that case we will have to understand the sign conventions. So let's begin with the sign conventions. Like if the heat is absorbed by the system, if the heat is absorbed by the system, Q is positive. If the heat is released, Q is negative. So this is pretty easy to understand, right? So I'll draw this diagram for you for easy understanding. This is system, and the remaining part is surrounding, right? So if the heat is absorbed by the system, it is positive, and if heat is released by the system to the surrounding, it is negative. Similarly, if we go for the concept of work done, if the work is done by the system, if the work is done by the system, listen carefully, if the work is done by the system on surrounding, we say that work done is positive. Similarly, if work is done on the system, if a work is done on the system by surrounding, we say that work done is negative. So hope like there is nothing much complicated in this, and hope you understand this sign convention. Why I am teaching you this sign convention is because it will be used widely when we solve numericals. So hope you understand this sign conventions, right? So heat and work can also be sometimes equals to 0. So this is the most important thing to note. Heat and work can also be 0. Now let's move on to other slide and see some more sign convention. I have prepared a specific chart for you to understand the sign conventions. Let's see it. So here we will not consider, I will not teach you the concept of enthalpy. It will be covered in our next video. Like the coming videos, it will be covered. For now, we are only concerned about the work, heat, and change in internal energy. So as explained previously, if the work is done by the system on surrounding, expansion work basically, uh, it is positive. It is considered to be positive. And if the work is done on system by the surrounding, the compression work, the work done is mostly negative. So if we were to look at the concept of heat, if like as previously explained, if the heat is absorbed by the system from the surrounding, the work done will be it will be positive, and if the heat is rejected by the system to the surrounding, it will be negative. Similarly, if we look for the change in internal energy, if there is an increase in internal energy of a system, it will be positive, and if there is decrease in the internal energy of a system, it will be considered as negative. I gave you an example of an inflating balloon, like when the balloon tied to the bottle, when it was placed inside a hot bowl, the internal energy increased. So in that case, I can say that the change in internal energy is positive. Similarly, when I put that bottle inside a cold water, the balloon deflated. So from that, I can say that there was decrease in internal energy. So the internal energy may be considered as negative when there is decrease in internal energy. So hope you understood this sign convention. Please let me know. Please just let me know in the comment section if you find anything difficult, if you find my explanation complex or not understanding it properly. Please let me know. It will help me to create more quality videos from next lecture on. So I hope you understood all those sign convention. You understood the first law of thermodynamics. You also understood the key takeaway that we took from the first law of thermodynamics. So hope you like my videos, and please do share and subscribe to my channel. Next video will be uploaded soon. It will be on the concept of heat engine, refrigerator, and we will also study the coefficient of performance. We will also study about the efficiency of the heat engine.
If this helped you understand physics better, like the video, share it with friends, and subscribe to Vision IB.